Hello, everyone. Welcome to our final project for Data Structures and Algorithms course for this semester. And we are from Group 2 of CSB, and we propose a project of optimal path selection of Hong Kong's MTR route based on Dijkstra's algorithm. So the group will consist of Ahmad, Dani, Nursanto, Izaaz, Rahman, Akbar, Izzeldin, Rayyan, Bastian, me, myself, Rabbani Nur Kumoro, and also Salsabila Alyanitazahra. So, the background of our project. Mass Transit Railroad, or MTR, is the leading public transport network utilized in Hong Kong. It consists of 10 routes that provide services to the urban areas of Hong Kong Island, Kowloon, and the New Territories with 166 stations, of which 98 are heavy rail stations and 68 are light rail stations. Tourism is a huge industry within itself in Hong Kong, and public transportation is a common amenity that tourists will use to traverse around due to its quickness and affordability. And an example would be the mass transit railroad network in Hong Kong. However, this might confuse the common tourist as it offers a wide variety of routes. Our problem is, as an example, suppose we are helping a group of tourists in Hong Kong and they are planning to visit Hong Kong Disneyland. The nearest MTR station from their hotel is Kennedy Town Station. They also want to calculate the shortest path, the alternative path, and the route length, and also the estimated time from the nearest MTR station to the Disneyland Park. So our proposed solution is to define the problem first into a graph. To use Dijkstra's algorithm, we must first construct the graph by declaring every node, path, and connected node. So each node represents a station in the MTR map. A simple graph representation of the MTR system map is shown below. And our goal is to find the shortest route, the alternative route, the route length, and the estimated time. And for this implementation, we will use Java programming language. And this implementation will also showcase which stations a person will have to pass through in order to reach their destination. The user might want to find the fastest route possible, or maybe would want to plan a few stops during the trip. And for the code functions, there are two classes. The first class is Dijkstra and also main. One is used for the graph representation and Dijkstra's algorithm implementation, while the other is for the testing. And below are some of the functions that are used for the features, such as Dijkstra method, void add edge, void Dijkstra alg, integer min index, and main method.
The first function that is going to be used in the Dextra class is called the Dextra method. This is the constructor for the object, and it initiates the attributes of the object, such as the number of nodes or stations and the matrices that are being used to represent the graph. There are two matrices to represent the same graph. The first matrix holds information about distance between stations, while the second matrix holds information about the time between stations. It also immediately adds edges to the graph, which means our graph is predetermined and unchangeable. The next function is called the void add edge. This adds a new edge and also determines the weight of it based on its real-life counterpart. The add edge method uses a similar method used to input new edges and nodes to a graph object. The constructor consists of 4 variables that will focus source node to the destination node, the weight of the edge, and a time variable used to calculate the sum of time needed to travel from one station to another. The next function is called the Dextra Algo. This is a function that implements Dijkstra's shortest path algorithm for a graph represented using an adjacency matrix. The algorithm is called recursively to print multiple paths. The first iteration prints the shortest path, and the next iterations print the alternative paths by deleting the edge that connects the destination and its parent of the previous path. It also loops recursively until no path can be made. The last function in the Dextra class is called the integer min index. This is a utility function to find the vertex with the minimum distance.
Next is the main method. The main method is what we use to test and execute our program. Essentially, our program is nested inside a do-while loop. First, it initiates the object of Dextra class inside the loop, and then it prints all of the stations available. The user will then be asked their starting and destination station out of all 98 stations available. If the input is not in any of the stations available, it will ask the user to re-input it. After getting the inputs, it will print all of the available paths. It will then ask the user whether they want to keep using the program or not. If they say yes, it will loop back to the beginning with the initialization of the object, because the graph is modified during the printing of the paths. So we need to reinitialize the object to reset the graph. If they say no, it ends the program.
So now during this demonstration, we will look at how the program looks and operates. First, we will be greeted with the following message. Welcome to Hong Kong Mass Transit Railway Guidance System. We will help you find the ideal route to reach your destination. Then, followed by the list of the station in the MTR system. There are 98 stations in total. Each station is represented by a number. After that, we are required to input the starting station and the destination station. This depends on the user. In this case, we will start from Kennedy Town, which is station number 75. And then we will stop at Disneyland Resort Station, which is station number 46. The program will then output the main or shortest path possible along with the route length and the minutes required for the trip. For the main route, it has route length of 79 and will take about 107 minutes to complete. If there were an alternative route available, the program will also print that out. But in this case, there are none. So it will state that no other route are found, then we choose if we would like to continue or not.
So suppose that the user enters an invalid input, which is out of the range of 1 until 98. For example, we input 0. It will say, please enter a valid input because there is no station 0. And another one, if we go over 98 or 100, it says the same thing. Please enter a valid input. So we need to input the correct number, which is 1 until 98. So for the next example, we will be choosing a path that has multiple routes, not just the main or shortest route. In this case, we'll be starting at Mei Fu, which is station number 31, and then stops at Hong Kong, which is station number 72. The output will show the main route and 3 other alternate routes. As the list of routes goes on, the route length and minutes required increases due to more stations being utilized. This may be useful if the user wants to stop at a certain station before reaching the final destination. We can then end the program, and then the following message will show. Thank you for using the Mass Transit Railway Guidance System. So in conclusion, we can conclude that this program is a smart and simple navigation system for finding the best route to reach our chosen destination. It came as a solution for the tourists to find the shortest path, alternative path, route length, and estimated time using Dijkstra's algorithm for their vacation. So we can conclude that the implementation is successful. Lastly, that is all from us. Thank you for your attention and goodbye.